Jai Hind everyone. I Neeraj Sharma, Assistant Professor EC Department at Akgec Engineering College, Ghaziabad. I am before you to present the video lecture for the complex topic series for the subject Microwave and Radar Engineering, whose subject code KEC 074. So this is my third video lecture. So in this lecture, I have chosen the topic Microwave Amplifier. So generally most of the amplifier we are studied at second year as well as in the third year, so which is used at the low frequency. But when we go on for the microwave frequency, that means we are moving toward the 1 gigahertz to 1000 gigahertz. So that means a very huge range, or the millimeter wave range we can move to the millimeter wave range. So at that time amplifier that we are using, that are the microwave amplifier. So what is this? And this is the one additional topic had been recently when the subject is been revised from the AKTU, and this topic will be added on. Okay, so in the syllabus. So now in this lecture I will try to explain the in detail for the microwave amplifier. What is microwave amplifier and how can it will work and how it will we can design. Okay, so in this we can see that. So the microwave amplifier, first of all, in the introductory section, we can say that this amplification is one of the most basic and prevalent microwave circuit function. This is the amplification, just to amplify the signal. So micro amplifier used klystron or traveling wave tubes or two terminal solid state devices such as tunnel or varactor diode. So from the two terminal we can also design the microwave amplifier. For that, examples are the klystron or traveling wave tube, and also this comes under the category of the microwave generation source, as well as due to the improvement in transistor processing technology that have occurred since 1970s, the most microwave amplifier uses the solid state devices, but these are the three terminal devices. Means with the help of three terminal solid state devices, the amplifier has been designed, such as the gallium arsenide field effect transistor. Also we can say that GaAsFET, one of the another category. Silicon bipolar transistor, heterojunction bipolar transistor, and high electron mobility transistor like HEMT. So these are the some another classification. So here the classifications of the designing of amplifier is based upon to the selection of the transistor. Either we are using the two terminal transistor or as well, so two terminal solid state devices or three terminal solid state devices that we are using here. So in this series I will focus on to the three terminal solid state devices. So when designing, for the designing of this microwave amplifier, so how we can design it. So in a brief I will explain few things in this lecture. The first one, that is the for the designing point of view, first of all we have to select the transistor. What transistor we are selecting for the designing of this microwave amplifier? Microwave amplifier. So in this first of all the selection. So in this selection, what we are using? Transistor selection. So this is the one more important criteria to check the transistor which we are going to use for the designing of this microwave amplifier. It is stable or not. At this condition, at the microwave, we can define it as an unconditional stability condition. Okay, so for that point of view, for unconditional instability, here we can go for the unconditional stability. Okay, but before going into the process, just let's say why we are going for this stability condition, how it is required. So for that point of view, just simple microwave amplifier circuit we have to design here. So in this we can simply, and a basic circuit for the general microwave amplifier design circuit is given by this figure that I am drawing here, that is the first of all, that is transistor, which is having some scattering matrix and having the gain of G naught at output terminal or at the input terminal, both things. Here we are using this input matching circuit, which is having the gain GS. This one is output matching circuit, which is having the gain GL, and it is now terminated with at output with load impedance Z0, and in as well as at the input it is having the source impedance Z0 with the source. So in this end it is having the reflection coefficient, input matching circuit have coefficient rho s, and here it is having the rho in. In the similar way, here transistor reflection coefficient rho out, and this is the rho L. This is simple and a basic general diagram for the microwave amplifier circuit. So in this designing, how can we achieve this matching? The stability term we are going here discuss for the this part transistor selection, and how the matching will be done, because some matching network we are connected, the source is connected to this transistor with this matching circuit, and the output is connected with this transistor with the help of this output matching circuit. So matching simply achieved when this rho s is equals to rho in and rho out is equals to the rho L. So we can get in this way. We have the now how can it will be possible? So for that point of view, what we are doing after selection of this stability, first of all we can now select the stability selection. We have to check first one. After that, what we can do in the stability condition, we are just input rho in less than condition 1 we will consider, and rho out less than condition we will consider, and the some locus point we will design here, we will create, and after that by plotting the these values onto the Smith chart, when the Smith chart is just outside the circle, so that with this will be define the output stability condition. So for that point of view, what we are this input matching circuit which converted into which is having some, means that input matching circuit at how much distance from this transistor from input, and how much length of the stub we have to connect it, so it will provide the matching to the transistor at source end. And the similar way, this from the Smith chart we can also find out the distance of the stub from the transistor to the output end, and the how much length of stub we can we have to connect. So that by in this way we can design an amplifier circuit with the help of Smith chart. So in this this is the simple microwave amplifier designing concept. Now now we can go into the detail. So for that first of all we are now going for the stability and checking the. So for that we are using the unstability condition, unconditional stability. So for unconditional stability will comes out when this rho in mod of rho in less than 1 and mod of rho out less than 1 for all passive sources and load impedances. So after that, when we will make this rho in is equals to 1, when we will make this rho in is equals to when the value of this rho in is equals to mod of S11 plus S12 S21 into rho L divided by 1 minus of S22 rho L. So we can make it 1, and after so we can now this rho L equals rho in is equals to 1 when we will do this condition. So we get some equation of the circle. When we can solve this condition, equation of circle we will get. So from that point of view we can get the value of this CL and RL. Similarly, what is the value of the CL? The value of the CL is equals to comes out that is S22 minus del of S11 conjugate whole conjugate divided by mod of S22 square minus of del square. Similarly, RL, this is the center which we can locate onto the Smith chart, and RL means radius at the load side, that is given by S12 into S21 S12 mod of S22 square minus of mod del square and whole mod. So this will be the value of the radius for the checking the stability condition. After that we can now draw in. After that we can go for mod of rho out less than 1. That means in this condition it is mod of rho out, it is given by mod of S22 plus S12 S21 into rho S upon 1 minus of S11 rho S of mole है sorry and when we will equate equals to 1, rho out equals to 1, then we can solve the value of the CS center. One equation we will circle equation we will after simplifying we get the equation for the circle. So the value of this center CS is given by S11 minus del S22 conjugate whole conjugate, and it is divided by mod of S11 square minus of del square, and RS is equals to S121 S21 divided by mod of S11 square minus of del square of whole mod. So this will be the center as well as, and this will be the value of this radius. So after selecting the values of CS and RS we can plot onto the Smith chart. Similarly, CL and RL we can also plot onto the we can on Smith chart, and we can find out the stability condition. So when these circles are outside the Smith chart, so it can be defined, the outside portion can be defined as the stability. And one another thing that we can go for just to design this stability condition, that we can also use the K delta test. This is also one an easy approach to find out the K delta stability of the transistor. So where we have to find out the value of this K and del. So when in this condition the K, in this K delta test, the K is given by 1 plus 1 minus of mod S11 square minus of mod S22 square plus del square divided by 2 mod of S12 into S21, and del is given by S11 into S22 minus S21 So in this way we can check the values of K and delta. If this K is greater than 1 and mod del is less than 1. So if this condition will satisfy, so it will specify that the transistor which we are going to use, that is the unconditionally stable. So in these two approach we can also design the we can also, what we can say, that the transistor that we are going to use, that is the unconditionally stable. So in this way we can check the stability. After checking the stability, then we can move for the single stage amplifier designing point of view. So we can now here have considered the single stage amplifier design. So there are some few approaches with that we can design this microwave amplifier. The first one, that is the design of maximum gain, that is the conjugate matching method. Second one is the constant gain circle and design of specified gain method. And one other important that most commonly used right now, that is the low noise amplifier, which is also comes under the category of the microwave amplifier. So in this I have just chosen the topic, first one, that is the design of maximum gain using this conjugate matching method. So in this conjugate means in this complex conjugate matching method, that what we can do, how can this matching will be provided. So as you can see this, how much maximum power this input matching transfer to this transistor, what will be the condition, and what is the maximum power transfer condition from that which can transfer the maximum power from transistor to the output matching condition. So this we can keep in the mind while designing this single stage amplifier design using the conjugate matching. So the maximum power transfer from input to transistor, okay, it is achieved by when rho in, when this rho in is equals to rho s conjugate. Similarly, maximum power from transistor to output circuit will be possible when rho out is equals to rho. In this way we can now provide the maximum power. So after we can simplify these values, so the value of this rho s, the value of this rho s is comes out B1 plus minus mod of B1 square minus of 4 mod C1 square divided by 2C1, because when we will solve these values in this case using the rho in is equals to S11, we can see here these values like for rho out, and this is for rho in, we can now use here in this method as well. So we can get this rho s and rho l we can get here, that is B2 plus minus of mod of B2 square minus of 4 mod C2 square divided by 2 C2, where these B1, B2, C1, C2 are the coefficient with whose value is given by B1, B2, C1, C2. So these values is now we can calculate given here, that is B1 is equals to 1 plus mod of S1, C1 is given by S11 minus of del S22 conjugate. Similarly, C2 is equals to S22 minus of del S11 conjugate. So these are the points which is given here. P1 for the matching of rho conjugate matching, rho n is equals to rho s conjugate. Rho s is given by this value B1 and C1. Rho l is given by B2 and C2. So B1 is 1 plus mod S11 square minus mod S22 square minus del square. B2 is equals to 1 plus mod S22 square minus mod S11 square minus of del square. C1 is S11 minus del S22 conjugate. C2 is equals to S22 minus of del S11 S22 minus del into S11 conjugate. So after getting these values B1, B2, C1, C2, we can now plot it onto the Smith chart, and after the plotting on these value onto the Smith chart, we can design the some any amplifier circuit. So what will happen, how can it will be looks like? So for that point of view, just I am using here one of the circuit. Let's say the transistor which is now given as, this is simple a transistor, this part is input matching, this is output matching. So how it can be? So for that point of view, we are selecting B1, C1 for input end, B2, C2 for output end. So how we can get this? How can we? So after that, what we can do after solving these value, we at some distance of this 50 ohm impedance, some distance value at of some length of stub. This is also in 50 ohm. We are using here. Just a minute. So this will be the transistor of few distance of stub is connected of some length is connected onto the output matching circuit. Similarly, rho s is equals to rho in conjugate condition. This one we can now connect the at distance one another stub of some distance at of some length we can connect at the input end. So in this way we can now design the any amplifier onto the we can design the microwave in this process. This is simple and a complex conjugate. We can also use the specified gain method. We can also design also with the low noise amplifier. We can also design with the use of some noise. So this is the now from my side for the microwave amplifier. So the references you can I have referred that is here D. M. Pozar. Thank you and Jai Hind.